Okay, let's dive in. We've talked a lot about JavaScript in the browser, front end stuff. But today we're shifting gears. We're going back end with Node.js and NPM.
Yeah, and this isn't just like theoretical. This is the engine under the hood for so many tools you probably use every day.
It's like the SFDX CLI, right? Or your LWC dev server and testing setups.
Exactly. All Node.js. And the key thing to grasp, first off, is Node isn't another language. It's a runtime. It takes JavaScript using Google's V8 engine super fast, same as Chrome, and lets it run outside the browser on a server.
Okay, so right away, that changes things. In the browser, our main global thing is window, access to the page, the DOM, take away the browser. What's the global context in Node?
That's a great question. It's the global object. That's your entry point. Instead of the DOM, global gives you server-side things, access to the file system, OS details, the process object, crucial stuff.
So different environment, different global scope. Makes sense. And this server-side context enables nodes, like main selling point, doesn't it? The performance, that non-blocking I/O.
Precisely. It's all about handling slow operations without waiting. Think about traditional server languages. If they need to read a file from a disk, which is slow, they often just stop, wait for the file.
Like a single-threaded waiter stuck waiting for one slow order while other tables need drinks.
Exactly like that. Node avoids the wait problem. When it hits something slow, like reading that file, it says, okay, system, handle this. It hands the task off, maybe to a worker thread in its thread pool, and immediately goes back to its main job, the event loop, ready for the next request.
So it delegates the slow work.
Right. And when that slow task, like the file read, is finally done, the result comes back with its associated callback function. That function gets put in a queue, and the event loop picks it up when it's free. The server never idles just because it's waiting on disk I/O or a network call.
So it can juggle tons of requests concurrently. That's the magic.
It's the core performance advantage, yeah. Thousands of connections handled efficiently.
Okay, so to make this happen, Node gives you tools, right? Built-in modules.
Yep. Core modules you don't even need NPM for, initially. Two absolute essentials are fs and path.
FS for file system.
Right. Reading files, writing files. But the crucial thing here is you almost always want the asynchronous versions, like fs.read file, not fs.read file sync.
Why? Because read file sync would block.
Exactly. Using the sync version freezes that event loop. It makes Node behave like those older synchronous systems. You lose the whole benefit.
Got it. Stick to async. And path? What's that for?
Path handles, well, file paths. Seems simple, but Windows uses backslashes, Mac and Linux use forward slashes. If you hardcode paths, your code breaks on different systems. Path.join is your friend here. It figures out the correct slashes for whatever OS it's running on. Makes your code portable.
Super important for compatibility.
Wow.
Okay, module systems. We still see both, right? CommonJS and ES modules.
We do. CommonJS is the older style in Node that's required to import, and module.exports to export things.
And the newer one.
ES modules, or ESM. That's the import and export keywords you probably know from modern front-end JavaScript, like in LWC. Node supports both. You might see files ending in .mjs specifically for ES modules sometimes.
Good to recognize both. All right, let's talk dependencies. NPM, Node Package Manager, and the package.json file.
Can't live without it. NPM manages all the external code libraries your project needs, and package.json lists them out.
And there's a key distinction listeners need to nail, especially for like deployments, dependencies versus dev dependencies.
Yes, this is critical. Dependencies are the packages your application absolutely needs to run in production. Think a web framework like Express or maybe a database driver.
Stuff the live app uses.
Right. Then dev dependencies are things you only need for development or testing.
Like just for running tests. Or Webpack for bundling code.
Perfect examples. Linters build tools, testing frameworks. They aren't needed once the app is built and deployed, so they go in dev dependencies.
And separating them helps keep the final deployed package smaller and cleaner.
Exactly. Deployment tools often skip installing dev dependencies. Oh, and don't forget the script section in package.json.
Yeah, the shortcuts.
Right, like setting up npm run test to execute a really long, complex test command. Super useful for simplifying workflows.
So bringing it all together for, our listeners, understanding Node means understanding how tools like the SFDX CLI actually operate, how LWC local dev works.
And how your jest tests run in that Node environment. It's all connected.
So the big takeaway.
I'd say the biggest conceptual leap is really embracing that non-blocking asynchronous model. It requires thinking differently, using callbacks, promises, async await. It feels more complex at first, maybe, but that complexity buys you incredible performance and the ability to handle tons of users without making anyone wait for someone else's slow operation. That's the power of Node's architecture.